This video is brought to you by TS4U IT Engineering Bootcamp.
So I would like to actually, so we are good with the Docker. I would like to go with the, I think you had mentioned in your resume that you have been using the orchestration tools of the platform as Kubernetes. So I just want to, with the basic questions. So what is your Kubernetes experience, 1 to 10? 1 is your novice and 10 is your expert. What is your experience, the number?
So I'd say 7.
Thank you. So your experience 7. So I can at least I can ask you some questions. So can you please describe the Kubernetes experience you have in your current project, or the overall? Just give an idea your experience, your contribution about Kubernetes.
Okay, cool. Thanks. So basically, we have been using Kubernetes in various ways. So if you ask me about our environments, like how does our environment actually looks like, so we have multiple environments for like helping with the developers and like the QA testers. We have the staging environment, we have the production environment, and we like sometimes have a like different environments for just testing specific features only. Okay, so for all those environments, we basically leverage Kubernetes because Kubernetes lets us has a like namespace environment. Okay, so let's say we have our dev environment, and that is entirely handled by our dev cluster. Okay, so we have a Kubernetes cluster for dev, and there we basically use a Kubernetes cluster launched with COPS. Okay, we run on like mostly on AWS, so we just use like AWS specific tools, and wherever we can, we like save money, like because cost is a like specific part of our system, and we always try to reduce the bills and everything. So for the dev environment and the staging environment as well, we basically use the COPS as our Kubernetes cluster manager. And if you ask me why did we go for COPS, so COPS is a like very good way to run Kubernetes clusters because we just need to specify our environments requirement. Like, okay, these are the number of nodes that I want, these are the number of masters that I want, and then we just need to give them the like configuration parameters. Let's say this is my AWS access token, this is my AWS access key ID, and then it will just create the cluster right away. So this is a self-managed cluster, obviously, and this does not have the EKS that AWS offers as the managed Kubernetes cluster. So for the dev clusters, and like we had staging first at the COPS, but later we went to the EKS. So basically right now we have the staging, not the staging, the QA and the like what do you have, the dev cluster on the COPS. Okay, so this actually saves us a lot of money. And for some instances, we basically have the spot instances as our node group. So using spot instances, we can reduce the bill like as well, because for the spot instances, AWS actually bills us 50% less. So wherever we can, we actually save money. So if we go for the COPS, we can actually control whatever environment we have at our hand. And then, okay, let's say we need to upgrade, we just use COPS and we just run 2 or 3 commands, and then just COPS actually upgrades the cluster for us. And since this is the dev environment, we also have the ability to upgrade the Kubernetes cluster to see how our application actually reacts with the newer version of the Kubernetes. So that's what the dev environment looks like mostly. And we kind of have all of our automated pipelines deploying through the like GitLab CI to this dev cluster whenever a developer actually pushes a new commit onto our develop branch. So we use GitLab as Git, and then we have a develop branch that has the like default branch tag, so that every time there is a like commit being pushed on the develop branch, that new commit is immediately deployed onto the dev cluster. Okay, so this is how we immediately know that, okay, if this build is having issues on the older uh, code base or not, because we run the integration test pipeline as well with that. So it basically like runs the entire test. So that's how the dev cluster is designed. And there we basically have the Kubernetes deployments, we have the Kubernetes services to communicate with the networking stuffs. And then we have some PVCs, we have some like what do you call ingresses in order to access our systems. So for the dev cluster, we basically have multiple domains as well. So all of those domains are basically used with the ingress to access our like dev environment. So we have dev 1, we have dev 2, all the way up to dev 6. So it's kind of like dev 6 dot something and dot example.com. It's kind of like that. Okay, so we basically have different namespaces onto our dev cluster, and then every single namespace has one version of the like development environment, so that we can actually test each feature on the dev cluster separately with a different domain. So that like this is very helpful for the like QA testers as well. And for the staging environment, we basically had a COPS cluster, but later on we upgraded it to EKS as well, because from the team we had a discussion that, okay, since this is just staging, so staging should be similar as the production. Okay, so we always ran production on the EKS, the Elastic Kubernetes cluster from the AWS managed Kubernetes solution. So at first we had this difference on the staging and the production cluster, because production was on EKS, and the staging was on the COPS. So later on, we basically decided that, okay, let's go for the EKS for both. Okay, and we regularly update our clusters. So we basically like wanted a single flow where we can update the staging and the production at the same time, because we can't just upgrade our cluster on the production before testing it on our own, right? So we didn't want to have that risk, so we just replaced our old COPS staging cluster with the newer EKS cluster, so that now every time we need to upgrade our cluster, we basically upgrade the staging first, look at the outcomes that, okay, if this is actually putting issues onto our applications, we test it thoroughly, and then we go for the update on the production. Because like in Kubernetes, if we just upgrade the cluster, something's always fail. Okay, so that's why we basically have the staging and the production as the same. So running EKS is kind of easy. We use the tool EKS CTL to launch our clusters. We basically have our like Terraform as our ISA tool. So we kind of integrated the EKS CTL provider with our Terraform providers. Okay, so that whenever we like want to create a new cluster, it uses Terraform with AKS kernel, so that we have a like new cluster with the best practices enabled. We could always use the default Terraform provider for like Kubernetes. We basically have a Kubernetes module for from Terraform, but what we always wanted in the Kubernetes clusters, that this thing would be secure, this thing would follow the best practices. And the best way to get the like best practices in an EKS cluster, EKS CTL was the only way for us. Like it had everything from the VPC creations processes, from the upgrading to a newer cluster system, like everything had there. So that's why we basically couldn't ditch the EKS CTL. So we just use the EKS CTL provider with our Terraform to like ensure that, okay, this is how our cluster is being launched. Okay, and after that, everything is kind of similar with the staging cluster and the production cluster. So I have been creating the deployments with the Terraform. So previously with the COPS, we couldn't use the Terraform directly, and we didn't at first. So we were writing the deployment YAML files, and sometimes we were using the customize, so that we can actually have like one single YAML file for deploying multiple applications into multiple environments. Okay, so that we can just reuse the same YAML for all of our environments. So that's why we are using customize. But after we implemented Terraform, we basically terraform everything. because with the Terraform, we can have a specific way to write things. And then if a new like joinee that is actually joined on our like team, they can actually understand the whole system just by going through our Terraform code. So this was a great help for us. It's kind of automated documentation. So with the Terraform, we basically create all of our deployments. Now we create even our databases actually runs on Kubernetes. So we ran all of our database installation Helm scripts with the Terraform. Okay, so we kind of use everything that we can. So we use the Helm, we use the Kubernetes like own set of tools like Argo CD in order to like update the deployments from time to time as well. So yeah, that's been my Kubernetes experience. And if I may add, on the networking side, we basically maintain the namespaces for all of the environments and for all of the applications. For example, our database actually has a different namespace. Our RabbitMQ, that is the message queue, that has its own namespace. And then we have the GitLab runner that runs inside the Kubernetes as well. So it has its own namespace. And then our application has its own namespace. So we kind of like namespace everything so that we can reuse different components easily. So yeah, that's the thing. And then we use the EBS CSI controller from AWS to access and create PVCs from the AWS EBS system, right? So that we can have our data stored on a like static volume so that none of our data gets lost. And after that, we basically use Ingress. So in order to Use Ingress, COPS was easy part. For the EKS, we basically need to have the AWS ELB controller so that the Ingress can actually communicate to the AWS ELB to launch a load balancer and yeah, like serve our application over the load balancer. So for every single environment, we basically have one Ingress, and we have that Ingress pointed to a AWS load balancer, that's the ALB, and we basically have all of our SSL certificates and all the authentications on that ALB side, and this actually helps scaling as well. So yeah, that's pretty much the Kubernetes environment that we have, and this is where I've been working on for the last 2 years. I can't hear you, sorry.
Thank you. You have answered so many other questions that I was going to ask. I have a couple more follow-up questions, so let's continue with those questions. Yeah. So I think you mentioned, but I want to hear a little bit more. What are the difference between service and ingress? I think you mentioned about the ingress.
Yeah.
Can you please mention that?
Okay, so
fine.
Yeah, sure. Thanks. So as for the services go, so Kubernetes actually has its own little DNS server. So we always use the core DNS, right? So core DNS is used internally for Kubernetes to like get the DNS for each services. So all the services that are deployed in Kubernetes, they have their own DNS, right? So let's say I want to like access my backend from my front end. Okay, so we don't need to provide a whole new endpoint for that. Since they both are on the Kubernetes, it doesn't matter if they are on different namespaces or not. Every single service in Kubernetes will have their own DNS. So whenever we have a deployment on Kubernetes, we basically have a service for that deployment. So deployment actually creates the pod, and those pods don't have their own services or don't have their own addresses. So in order to reach to those pods, we basically need to deploy a service. Okay, that is a Kubernetes manifest or Kubernetes feature that enables us to communicate from one pod to another pod. Okay, so if we have a front end and we have a back end, then the front end will have its own service, and then the backend will have its own service. So both of the services will be able to communicate through themselves based on their names. Okay, so this is internal network calls. But if we want to reach to our pods from the outside of the cluster, then we don't have a way to call our services because services are cluster only. Then we basically need the ingress that actually exposes our internal services with the node port and lets us access based on the load balancer. Like in the ingress, if we go for the managed cloud, we basically need a load balancer in order to implement the ingress. Okay, so ingress actually uses the node port of the specific service, and then it connects that node port as a target group in the load balancer, so that load balancer knows where to go. Okay, so I would say, to summarize things, services we use for internal calls, and for the ingress we basically use it to reach to our system from the outside. So it's basically for our customers.
Got it. Thank you.